Good morning. This is section 2.2, Operations with Fractions, part 1. So there's no handout with this one. I've written in some things just so that I don't have to waste your time with the video watching me write it out. So if you wanted to hit pause and write in these things, that's fine. Or if you just want to hit pause as we go, or if you want to try to keep up as we go, all those are good options. Okay, so first, we're going to go through some of these different things like division by 0, multiply by 1, just talk about what that looks like, okay? So for the first one, division by 0. So what that means is that we can't divide by 0, okay? So if we're talking about a fraction, if we have a over b, if b was 0, that would be undefined. So I'm going to put is undefined if b equals 0. Okay, so in a fraction, you can't have a 0 on the bottom because a over b is saying a divided by b, and we can't divide by 0. Next, when we multiply by 1, so if I had a times 1, what would that equal? Just equal a, right? So anything times 1 is itself, is what this part is saying. And the next one, a divided by 1, right, would just be a over 1, like this. That would also just equal a. So these two pieces, multiply by 1 is just saying that multiplying by 1 will stay itself. Dividing by 1 is showing you that if we have a 1 on the bottom of a fraction, all we have to do is just write out the top, okay? Dividing a number by itself. So if we had a over a, what do you think we would get? So say if we had like 5 over 5, like we have 5 people, 5 candy bars, we want to divide them up, each person will get 1, right? So this is telling you that anything over itself just equals 1. When we multiply fractions, so say if we had a over b times c over d, we just multiply straight across the top and straight across the bottom. So we would have AC over BD. Dividing by fractions, this one's a little bit more complicated. So if we had just one more little step here. So if we had A over B divided by C over D, what we do with fractions is we do keep, change, flip. So that means that we keep the first part. So we'd have A over B. We would change the sign. So we change it to multiply. And then finally we flip the last guy. So D over C. And then we can go ahead and just multiply straight across the top for an A times D over straight across the bottom, B times C. There is an explanation that I have for that about the keep, change, flip. It probably takes 10 or 15 minutes or so to do, and a lot of students are interested in it, so I'm not going to waste your time by showing you that. But if you are interested in that, I can send you a link to an explanation to why the keep, change, flip works when we divide by fractions, okay? Next, we're getting close here through all the vocab. The add fractions. Whenever we add and subtract fractions, we need to have the same denominator, okay? Multiply and divide, it doesn't matter because we just go straight across the top and across the bottom. But whenever we add and subtract, we have to have that same denominator. So if we had A over B plus C over, I want that same denominator, we would combine the top, A plus C, over that combined denominator of B. And same thing with fractions. If we had A over B minus a C over B, we would subtract the top and keep that same denominator. Next, we have a prime number is any counting number larger than 1 whose only positive factors are itself and 1. So prime numbers, 2 would work because 2 doesn't have any factors that go into it besides itself and 1. How about 3? Yeah, 3 would work. Would 4 work? 4 would not work because some factors of 4 would be 2 times 2. So it has other factors besides itself and 1. 5 would work. Is 6 prime? 6 is not prime because 2 times 3 is 6. How about 7? Yeah, 7's prime. How about 8, 9, 10, 11 would work, right? 11's prime because I can't think of two numbers that multiply to give me 11 besides itself and 1. And you can work through these, like 12 wouldn't work, 13 though is prime. 14, 15, 16, 17 is our next one. And then just to keep it going, we'd have 19, 23, 29, and it would still just keep on going on and on and on. I think you get the idea. Okay, so those are our prime numbers. So when we have some of these problems, like example 1 says, write 54 as a product of primes. There are some people that they can just look at that and they can just tell me what the product is. If you are that person, awesome. I cannot do that. What I like to do, my most favorite thing to do on these problems is to make a little factoring tree. So what I do is I write the 54 and then I give myself 2 branches and I think of 2 things that multiply to that number. And I just keep going until every very end of my branch is prime. Okay, so 54 is 6 times 9, right? Now, are those prime numbers? They are not, because we can branch off 6 is 2 times 3. And once I get a prime, I like to circle it so I know that I'm done with that branch. And 9 is 3 times 3. So now I have all primes across the bottom. So if I were to write 54 as a product of primes, so we'd actually write it out with the multiplication, we would write 2 times 3 times 3 times 3. And then if you wanted to check your answer, you could go back and do 2 times 3, figure out what that is, go times 3 times 3, and you would get 54. All right, next, simplify 4 over 6. I'm pretty sure almost all of you, probably actually all of you, can just see that and say, oh, it's just 2/3, because you're just dividing the top and the bottom by 2. I'm going to show you, it's going to look weird, it's going to look strange, but if you can understand it in this class, it's going to make factoring way easier in Math 90. So I'm going to show you this kind of longer way to do it. Is we're going to write the top as a product of primes and the bottom, and then we're going to do what's called removing a factor of 1. Okay, so, and again, this is going to make Math 90 so much easier if we can try to understand this concept now. So 4 is 2 times 2, right? 6 is 2 times 3. Now what they want us to see is this removing a factor of 1. So do you remember at the beginning where we had a over a equals 1, so anything divided by itself was 1? So do you see this 2 over 2? Some people like to cross them off just to kind of really make the point clear. I'm going to change it to just a giant 1. So 2 over 2 is 1. I'm going to write removing a factor of 1. So when I do that, 2 over 2, since that's just 1, all we have left is that 2 over 3. Take a look at this one. Example 3, 30 over 42. See if you can do that the same way that we just did the last one, where we wrote out all the prime factors up top, prime factors across the bottom, and removed a factor of 1. Okay, so try that real quick. Come back when you're ready. All right, so again, when I see this, 30 is kind of a big number. I'm thinking 10 and 3, but I know 10's not prime, or 6 and 5. So just to be safe, I like to make a little tree off to the side. So I'm going to go with 5 and 6. 5's prime, so I know that's in there. 6 is 2 and 3. And sometimes students, they'll ask me, what if they had picked 3 and 10? And it would work as well. I'm going to do it real quick just so that you can see, and then I'm going to erase it, okay? So you can see it's 2 times 3 times 5, right? 2 times 3 times 5. So for 30, if you had picked 3 and 10, 3 is prime, so then you break apart the 10 to 2 and 5. And there you can see you would have had the 2 times 3 times 5. Okay, so same thing. I'm going to erase it, though, so it doesn't look too confusing. All right, so we have the top. Let's see, 42. Let's make a little tree for that one. Let's see if I can squeeze it in over here. 42 is 7 is prime times 6. And 6 I'm going to break down to 2 and 3. And when I write it over here in my fraction, I like to just put it in order lowest to smallest, just because I can make that removing a factor of 1 look a little bit easier. Okay, so now we look for what's the same on the top, what's the same on the bottom. So again, you could go like this. A lot of people go 2, 2, 3, 3. You can do that and cross them off just to really drive home the point here, or the removing a factor of 1. I'm going to cross them off like this, but you don't have to if you prefer the other way. Okay, and we're left with 5/7. All right, here's our next one. Going to simplify these guys here. So we have an 8/9 times 15/4. So if we were to multiply straight across the top, that would end up being a huge number, right? So before we start multiplying, let's see if we can reduce. So do you see that 8 up top and then the 4 on the bottom? So what that's saying is 8/4. Is there a different way we could write 8/4? Yeah, it could reduce down to 2/1, right? So I'm going to go like this. I'm going to cross out the 8 and go 2/1. Now, how about that 15/9? We could divide the top and the bottom, that 15 and the 9, both by 3. So let's reduce it. So we have 5/3. So now our new fractions are way smaller. Now we have 2/3 times 5/1. Let's go and multiply across the top. And so 2 times 5 is a 10. Over across the bottom, a 3 times 1, we'd get a 3. All right, very good. Let's go and do the next one. Here's division. So remember, in division, we do keep, change, flip. So we would keep the first one, change the sign from division to multiplication, and then flip that last one. So instead of 1/8, I have 8/1. See if you can do that little cross-canceling skill that we just learned on that last one. See if you can do that, and then go and multiply across the top and bottom. See what you get. Come back when you're ready. Okay, so the 3/1 I can't reduce. 8/4 I can write as 2/1. Now I have 3/1 times 2/1. So 3 times 2 is a 6. And then technically it is an over 1. But remember earlier we realized that a number divided by 1 was just itself. So it would look kind of silly to have that over 1. We don't need that. So our answer is just 6. All right, let's see. I think we're getting close. We just have 3 more, okay? We're going to be adding and subtracting these fractions. So for my first one, I have 5/8 plus 5/6. Now, I can't just add across the top, add across the bottom. That's not going to work, okay? I need to find common denominators. There's a few different ways to do it. My favorite way is I list off multiples of both fractions, both denominators. Okay, so for 8, I would have 8, 16, 24, 32. That would just keep on going. For 6, I have a 6, a 12, an 18, a 24, and that would keep on going. Do you see one of those multiples that they have in common? Yeah, look at that. They both have the 24. We want to pick the smallest multiple that they have in common. So they both share that 24, right? So now let's rewrite this and put equals over 24 plus over 24. I want 24 to be my new common denominator. So watch this part closely here. If I have 8 and I'm scaling it up, 8 to 24, what am I multiplying that by? 8 times 3. Okay, so I'm going to put a little times 3 is 24. So if I blew up the bottom of my fraction by doing times 3, I need to do that to the top. So 5 times 3, I get 15. Okay, now if I had 6 and now I'm blowing it up to a giant 24, I'm multiplying it by 4, right? 6 times 4 is 24. So whatever I do to the bottom, I need to blow up my fraction the same on the top to keep it consistent. So 5 times 4, I would get 20. Now that I have common denominators, now I can finally just add across the top, which is 15 plus 20. So I'll go ahead and write in 35 over that common denominator of 24. And that one at first, it feels like you can simplify it, but once you kind of play around with it a little bit, you realize that it's reduced. You can't simplify it anymore, so leave it just like that. Some people also want to convert it to a mixed number. Don't worry about that. Leave it just like it is. Okay, that's perfect. Go ahead and try this one. So for D, go ahead and try to figure out what would be your common denominator. Go ahead and blow up those fractions and then combine. Okay, come back when you're ready. All right, so far I found my common denominator. So I listed out all the multiples of 9 and 5 until I had a common one, the lowest common denominator. I got 45. Okay, so if you didn't quite get this far yet, go ahead and hit pause now and try to finish it off. Otherwise, let's see what we can do. Okay, so scaling this up, 9 times what gives me 45? Times 5, right? And so if I blew up the bottom by 5, have to blow up the top by 5. What's 8 times 5? 40. Minus. Now I have this 5 on the bottom. What do I have to multiply 5 by to get it up to that 45? Multiply it by 9. Okay, blow up the top. Same amount. 3 times 9, 27. So now we have those common denominators, so we can subtract. So we have 40 minus 27 would equal 13 over our common denominator is 45. All right, we're all done with that one. And our final one here is a little bit confusing because there's something extra going on, okay? So let's take a look at it together. So this is going to equal. Now with the 3 and the 6, do you know what their common denominator is? You might not know. So let's list off a couple here. So we'll go 3, 6, 9. And then for the 6, 6, 12. So which one was it? What was common? That's 6, right? So now what we're going to do is we're going to make it so that every single one of these, even the 1, has a 6 on the bottom. Okay? Are you with me? So I saw that the 6 was the common denominator. of the 3 and the 6, because those are the fractions. So the 1, I'm going to force it to be a fraction so I can do my subtraction. Okay, so I have, so far as something over 6 minus something over 6 minus something over 6. Almost looks like we're going to play a hangman game or something with all these blanks, right? So let's go ahead and, now that 1 over 6, can we do anything with that? No. So let's go ahead and just rewrite it. That stays the same, 1 over 6. That's the easy one, right? The 1 over 3, I'll go ahead and draw on a line. I hope this isn't too confusing. 3 to get to the 6 was times 2, right? So since I blew up the bottom by 2, we're going to blow up the top. So 1 times 2, I have a 2. So another way to write 1 over 3 is 2 over 6. This is one that kind of throws people off sometimes. This 1, what's another way to write 1 is anything over itself, right? So since I have a 6, let's change that 1 to be a 6 over 6 so that it matches with the other 6 across the bottom so we can subtract. Okay, so now watch this. I'm not sure how many steps I want to do because I don't want to lose anybody. Let's write it all out. You don't have to write as much. You don't have to include this step, but I just don't want to lose anybody. So across the bottom, we now have that common denominator, right? So up the top, I would have a 6 minus a 2 minus a 1. Okay, do you see that? So I have 6 minus 2, I would get 4. Minus 1, I would get 3. Over 6, which I can reduce down to 1/2. All right, hopefully that wasn't too bad. That is it for today. For tomorrow is a lot of extra practice, okay? So I really want you to practice these things. So the activity for tomorrow is going to be seeing how much of a Jeopardy game you can work through. All right, so that link will be posted tomorrow. I hope you have an amazing day. Good job.